My name is Diane Hansen, and I'm a senior animal science and agricultural literacy major here at CSU. In addition to being involved with several organizations on campus like Ag Ambassadors, Livestock Association, and Ag Council, I had the opportunity to work with Elanco Animal Health this last summer as a food animal marketing intern, where I really got to identify my values and passion for agriculture within the cattle industry and my desire to work with producers to help them continually improve their operations. I'm pleased to have the honor of introducing our afternoon's keynote speaker today, Dr. Sally Rockey. Dr. Sally Rockey became the inaugural executive director of the Foundation for Food and Agricultural Research in September 2015. Prior to this role, Dr. Rockey was an award-winning leader in federal research. She spent 19 years with the U.S. Department of Agriculture, where she held a number of positions with the Cooperative State Research, Education, and Extension Service. Very early in her career, she became the head of the Competitive Grants Program, overseeing extramural grants, process, and portfolios. Dr. Rockey brought her experience in agriculture research to an 11-year career at the National Institutes of Health, where she emphasized the connection between agriculture, food, and health. As Deputy Director for Extramural Research, Dr. Rockey oversaw the operations of the largest federal extramural research program and led groundbreaking initiatives and activities that have and will have a lasting impact on the research community. Dr. Rockey received her PhD in entomology from Ohio State University. She has devoted her career to improving people's lives through research and plans to continue this mission by seeing FFAR become an essential component of the scientific enterprise. Please join me in welcoming Dr. Sally Rockey.
Thank you, Diane. Just one error in your introduction. It is TOSU, the Ohio State University. We must have a Buckeye in the audience there. I-O. Well, thanks so much for having me. This is just a delight to be at this event and being here at CSU. I was trying to think back whether or not I've ever been here before, and I'm sure I have in my career, but it's just an inspiration to see the beauty and actually the talent and the innovation that's going on in this very room and across campus. So I was going to talk about public-private partnership, but I'd like to begin by just talking a little bit about agriculture and some of the things that we're seeing. As you heard earlier today, we'll need 60 to 100% more food by 2050. There's the talk of having 9 to 10 billion people on this planet by then. So we need to produce more food. We have to do that in an environmentally sound way, preserving our water resources and having the least amount of input on our environment. Just to demonstrate some of the things that happen, this is the Aral Sea. I don't know if you know the Aral Sea. It was at one time one of the largest lakes in the world. It's between Uzbekistan and Kazakhstan. And it, over time, has been totally depleted for agricultural purposes. In fact, it is so depleted that the eastern part of this lake is now called the Aral Desert. And all of this water was redirected towards agriculture. So we've had some dramatic things happen as a result of agriculture across the world. These are rainforests, how we look at rainforests when we deplete rainforests, for example. We increase greenhouse gases. 25% of all greenhouse gases come from agriculture. So we have these grand challenges. We have to feed the world, we have competing resources, we have climate change, we have to be environmental stewards, and we have to improve health and nutrition. So we all have to really come together to face these grand challenges. And I'd like to say that particularly in this country, agriculture is the solution. And all of the great sustainable practices that our producers are practicing out in their field are contributing to our being able to continue to feed the world in a sustainable way, including being able to be environmentally resistant. As we heard earlier, there's so much different weather that's going on and weather variability, we have to be able to do it. So innovation is where we can solve the problems of agriculture. And when I left the USDA in 2004 and was 11-year hiatus at NIH, I came back to an agriculture and an agricultural sciences that had totally changed. It was just incredible in that decade how advanced and cutting edge agricultural sciences had become. And so I've been so excited to be able to be back as part of the foundation and to really be part of this new innovation that's going on. And if we think about some of the things that are happening in science right now, science is accelerating at speeds we cannot even imagine. We produce more data in the past 2 years than in the history of our time on this planet. And we have to take advantage of this incredible acceleration in science, because if we don't, we're left behind, right? I mean, things that happen today and discoveries that happen today and new technologies that are developed today become old-fashioned tomorrow. I mean, it's incredible how fast things are really going. So we in agriculture are primed to take advantage of all the innovation that you and others are producing in this world. Let me tell you a little bit about how fast things are accelerating. I use the example of DNA sequencing. DNA sequencing has become 1 billion times faster and cheaper in the past 25 years. Now, what does 1 billion times mean? We can't even really think about what 1 billion times means. If you look at how fast computers go, computers from the original computer to the computer of today is about 125,000 times faster. So what does 1 billion times faster look like? I like to use the example that Ed Buckler, who was one of the first recipient of the Food and Agriculture Prize at the National Academy, told me. He has a 3.7-mile walk to work, and he walks to work every day. It takes him about an hour to walk to work. If he was able to walk 1 billion times faster to work, he would walk to Pluto in an hour. So I love that, because that lets us visualize how things have sped up, how things are accelerating. It really does put it into perspective of what 1 billion times means. So how quickly can science make a difference? One of the advantages that we have in ag sciences is that agriculture research is applied out in the field, and agricultural science is applied out in the field more quickly than any other discipline. If you think about when you talk about basic science, they often say that we don't see the results for 20, 30 years. There's a big gray area in agriculture between what is basic science and what is applied sciences or translational sciences, because agriculture research science is translated so quickly. And here it shows that there's an influence of agriculture or productivity in as little as 2 years from ag sciences. If you consider that's an average, that's really absolutely incredible. We know how that we can do advanced breeding and put out new varieties of plants and have them in fields very, very quickly, as an example. But our impact of our science can oftentimes be felt for over 30 years. So it is just the greatest time to be in agricultural sciences right now. And I like to say that agricultural sciences are sexy science. It's a sexy science. We want to be there. We want to be in this science. And we're seeing a great acceleration of the number of startup companies. Many of you are represented in the room, the number of venture capitalists that are investing in agriculture, and just the way that we're able to attract people and scientists from throughout the different disciplines to come in and work in agriculture. There's never been a time like it. So again, what you're doing today to talk about the innovation that's needed is really where we need to be, so that we can put those problems together with the innovative solutions that are going to change the world and change agriculture. So if we think about it, let's think about innovations in agriculture. This was a list, I think it was in Forbes or the Atlantic, of the top most innovations that have shaped modern life. And unfortunately, we're not really in the top 10, although all of these things directly pertain to agriculture. Top 10 includes some things like electricity, internal combustion engine, paper, the internet, etc. But we come in at 11 with nitrogen fixation. We come in with refrigeration. Why do we want to refrigerate? Because we want to preserve food, right? So this is very agriculturally related. The green revolution and everything we know with Norman Borlaug, who brought advanced breeding to the world in order to feed the world. The moldboard plow. So this is an invention by Thomas Jefferson. So Thomas Jefferson went to Europe and studied how plowing was done in Europe and came back and said, I want a way to plow not only to get through the soil more quickly, but to be able to turn the soil more quickly so that I could plow in a rapid fashion. And so his invention, his innovation, was the moldboard plow. And if you think about it, innovation can come from anywhere and anyone. Thomas Jefferson was a very innovative person in the area of agriculture. But we think about something like the moldboard plow as something simple. But at the time, this was an incredible innovation in our world. So we have to think about what innovations means in the perspective of the landscape of present day. Cotton gin, 1793, pasteurization, and plant breeding, actually going back, of course, to the monk Gregor Mendel in 1866. So this has been, we're well represented in the agricultural sciences as the innovations that have really changed the world. Oh, I'm sorry, self-propelled combine harvester, 1930s, that happened as number 50, so that was wonderful. So again, as I'm saying, it's really the place to be right now, the importance of the issue, taking fundamental almost immediately into application. The other thing is that new technologies are often more applied to, or quickly applied to agriculture more than any other industry. Now, we heard this morning about whether or not we were going to have regulations or at least policies on animal genetics and new biotechnology. But in the area of plants, think how quickly we've taken gene editing and applied it to crop production. Many other examples there. One of the things that when I was at NIH, of course, you're dealing with an animal, right? You're dealing with the human animal, and the regulations beyond for working with humans is very astounding. So in many ways, because of our regulatory landscape, in some ways, some of the technologies are easier to implement to agriculture. But we're also really, innovation sucks, right? We want that innovation. We want to be able to change agriculture as quickly as possible, so we're looking for those innovations everywhere. And of course, as we know, and I'll talk a little bit at the end of our talk about how we should think about innovation in the consumer, just growing interest in how food is produced and about food that they eat. So the consumers are extraordinarily interested in the food system and their food. So we heard about many of these technologies this morning, all of our advanced genetic technologies, the data analytics, imaging, drones, GPS, blockchain, whole systems modeling, which we can do now because we have artificial intelligence and deep learning. So these are just some of the examples of some of the technologies that we are applying rapidly to agriculture. And our progress happens, I think I heard almost this exact term this morning, is progress happens when knowledge of how things work collides with our technological advances, which really leads to this great acceleration in progress. So one of the questions that I had was, why is agriculture research not commensurate with its funded, not in commensurate with its value? I came from NIH. NIH is now almost a $40 billion a year program, and it was amazing to see what putting funding behind a science can do to accelerate that science. Agriculture has enjoyed enormous bipartisan support on the Hill. Our friends on the Hill do everything they can for ag research, but the spectrum of it is quite different because of the limits of the level of funding to begin with. Kurt Vonnegut said, when it comes right down to it, food is practically the whole story every time. And it is. It's the basis of our lives and the basis of all people's lives. We eat 3 times a day. We don't always take medicine 3 times a day, but we eat 3 times a day. And one of the other things that I talked about when I was at NIH, I always gave props to agriculture when I talked of how basic science and biomedicine has led to an increase in our life expectancy. So our life expectancy is now about 80 for both men and women. Average, women's actually over 80 in the United States, and men is about 79. And in 1900, your life expectancy was 48. And so if you see this graph, life expectancy continues to go up. I will point out that in the last 2 years, life expectancy in this country has actually gone down. And that's as a result of a couple things: obesity epidemic, suicides, and the opioid crisis. But nonetheless, we've seen this great advancement. But I always said it's also due to agriculture and the advances we've made to agriculture. Think about infant mortality, and by having a nutritional, really nutritional nutrients for the mothers has decreased infant mortality. In the area of food safety that we've talked a lot about, not having to face as many foodborne diseases has really increased our life expectancy, and a whole host of eating more healthy food. So give those props to agriculture. Don't let NIH take all the credit, because it's both us and biomedicine. So I wanted to talk just a few minutes about my foundation, because this is a way that how stagnant funding actually led to the formation of our foundation. And I also want to call out Secretary Vilsack in the back of the room, who was instrumental in helping us form our foundation back in 2014, along with our friends in the Congress, who really saw this vision for having a new kind of funding in agriculture. So here's what led to it. Let me just show you what this chart means. If you look, that gigantic chart, Blake, wherever you are, is DOD funding, R&D funding. Down at the bottom, the large orange is NIH funding. And if you can see, I can point maybe with the pointer, maybe I can't reach that far, but if you look, that small gray line right above NIH is the USDA funding. So USDA funding represents about 2% of the R&D funding in the country. It's about 4% if you take out Department of Defense. So there was a need not only to raise the pool of funding for ag sciences, but also the way we fund ag sciences. So here's the other thing that's happened, that the amount of R&D that goes on, and particularly research as well, in the private sector has been growing by leaps and bounds. And if you can see here, the amount of R&D funding by the private sector eclipses the public sector funding by almost threefold. So there's a great opportunity there to take what is done in the private sector and bring the public sector to bear on those issues, and the private sector to bear on public sector issues, and to work together to advance agriculture. So we were created in 2014 as a 501c3 nonprofit. There are a number of other federal agencies that have a foundation. We are governed by a board of directors, and we are designed to complement the work of the USDA. So we work very, very closely with the USDA as probably our closest partner. And we have a wonderful vision. We envision a world where ever innovating and collaborative science provides every person access to affordable, nutritious food grown on thriving farms. So here's just our challenge areas. Actually, we're going through a revamping of our challenge areas for 2019. We're very hopeful that we'll be refunded in the next Farm Bill, and we'll be seeking public comment on our challenge areas. But these are most of the major issues facing agriculture, and we are embedded in all of these. So as I mentioned, this is the public-private partnership piece of this. One of the interesting aspects of us is not only do we aspire to have public-private partnerships, but we're required to have it, because our $200 million that came through the Farm Bill must be matched by a non-federal source. So I'm a little jealous of Blake at DARPA, because when he has an idea, he can go out and pursue it. We feel like we have that flexibility too, but we do have to find the partners that share our goals and objectives to come in together with us, and that can be a challenge, but also a great, great opportunity to find those other entities that fund with us. So we work directly and easily with our private sector partners. We have multiple investments. We have 20 donors, but we have about 3 times that many partners that have also funded with us. We are actually more than 1-to-1 matched. We're 1 to 1.4. We fill gaps when we see something that we hear either from our stakeholders, or we envision from our board, or we envision ourselves. We can go after it. And we have lots of input from the community. We have advisory councils. We have 6 advisory councils, which are composed of scientists, stakeholders, producers, other potential funders, private sector, et cetera, that help guide us in our projects. And we try to be nimble as possible. So when people come to us with great ideas, sometimes we launch a competitive grants program. Sometimes we can directly fund an idea that we really love and want to go after right away. So here's just an example of many of the groups that we've worked with and have funded with. You can see it ranges from from our commodity groups to our other foundations. Bill and Melinda Gates have been a wonderful partner with us, to some of the big food companies, General Mills, PepsiCo, to some of the retailers and the meat companies and a number of other groups. So we have worked with a variety of groups. So why do we engage in industry? Well, as I said, that take advantage of what's happening there. And also, where possible, we try to work in the pre-competitive space. Now, what does that mean? What does the pre-competitive space mean? I tried to figure this out. When I first started working at FAR, I tried to figure out what does pre-competitive mean. It really is in the eyes of the beholder, right? So, but I was able to find a definition for the competitive space. So the competitive space is areas of business in which the firm feels comfortable against competitive pressures on the basis of its cost advantage and or its technological leadership. So that's the competitive space. And I thought, well, what if I take those words in blue and just put an opposite in there? Would it make sense? And it absolutely makes no sense. Areas of business in which the firm feels uncomfortable against its unambitious relaxation on the basis of its cost disadvantage and or its technological inferiority. So folks, that is not the pre-competitive space. So I made up my own definition of pre-competitive space for research, areas of research where outcomes offer no particular advantage relative to peers, and where there's a potential to positively impact all parties. It allows resource and data to be readily shared in order to reach an end goal. So when we think about pre-competitive space, what we think about is where are different groups going to be willing to work together towards a common goal. Often it's an intractable issue that stymies science, that science can't move forward until we get over that issue. It might be something that is of interest to one company, but other companies then also can understand what this means and want to get into that game. We have a lot of different areas. It can be very fundamental questions. Oftentimes, pre-competitive space means we're going after fundamental questions, but sometimes it can be more applied questions that still are an obstacle to advancement. So why does the private sector have an incentive to work with us in the pre-competitive space? Remember now, they are oftentimes at the table with their direct competitors. And in some cases, those groups we've been able to work and form consortia together. Sometimes it's more difficult depending on who the members are of that pre-competitive space. So some of the things, though, that are incentive for them, they have corporate social responsibility. They like to look, particularly working with FAR, who has public sector money, that they're working for the public good. They can more readily adapt products where there's common obstacles, as I just mentioned. There are cost savings. So let's say you're going through a pathway to a gene. If you do that gene, it's either too high risk or too costly to go for it on your own as a corporation, perhaps. And so if you work together, you can have cost savings for it. They oftentimes get direct access to fundamental research that's going on at the university, so they get it in real time as it's emerging from the universities. They get access to excellent people, such as scientists in this room, and they also get access to students and trainees. So that's a really important part of what industry is looking for. The public sector has incentives too. We address real-world problems, so oftentimes many of the things that we work on, where we bring the private and public sector together, are very real-world problems. We generate research. We can say we're generating research that can be quickly transferred to the economy. We get access to resources and data that we otherwise wouldn't get. So getting also one way from the private sector getting access to university-based research, but university-based research getting access to data that could reside in the private sector that they may otherwise not have. And also they get access to excellent scientists as well. So it goes both ways for these consortia. So how do we make them work? Well, first of all, there has to be shared goals and values. So unless you share those goals, we put together, which I'll talk about in a moment, a consortium called Crops of the Future. We have right now 10 companies in there, soon to be 15. And I was very nervous when we first got together because I didn't know how this was going to work. And we had a very motherhood and apple pie vision statement for this consortium. And all of our members wanted to gather around that vision statement, which we had on a big card, and get a picture made with that vision statement. And I was so proud because these groups and these companies are putting aside their competitive nature and saying, we're going to work together for the public good. And I just was really proud of them for doing that. So they have to have their shared goals. You have to be open and transparent. That's absolutely essential. There has to be agreements on the rules of engagement. This is probably the single most thing that can destroy these public-private partnerships if you haven't agreed ahead of time to the rules of engagement. Transparent, there has to be trust among the members as well as trust that we're going to see something important emerge. There has to be synergy. So you can't form a public-private partnership if there's not going to be something that's greater. The whole is greater than its parts, right? You're not going to get people to join unless there is that synergy. And all skin in the game. This is another problem that we've had because we have large companies, small companies, we have some research organizations, we have some foundations, and not everybody can put in the same amount of money. So how do you work those deals to try to make sure that everybody, based on their size or their position, really has the same amount of skin in the game? And if you give a skin in the game, everyone's going to jointly celebrate the successes, and they're also going to have shared responsibility for any failures. So I've seen with my work at NIH, a number of our public-private partnerships succeed enormously. We're very hopeful in the couple that I'll mention here that we're doing. We're going to have that same kind of success in working them. Oh, and then engage stakeholders. You always want to have your stakeholders engaged and them to know that this private-public partnership is working for you, for them. So what are the toughest issues? So I did mention one of the issues is what do each of these companies represent in each other's minds? So we've had some interesting collaborations among groups that you never would think that would collaborate together. So we have had Open Philanthropy, which is a phenomenal foundation that was created by Moskovich. He was one of the co-founders of Facebook. They were very interested in animal rights and animal welfare. And we've had collaborative efforts between Open Philanthropy and some of our meat companies to working on some animal welfare issues that are huge issues for the industry. And so you have these strange bedfellows. Sometimes it works, sometimes it doesn't work, but for us, we view ourselves as a neutral arbitrator. We can bring them in to make sure that the science that's done is going to give us evidence-based, give us data that can be used for policy development and be evidence-based. So we like to think of ourselves as being able to successfully bring those people together, but it's tough because there are companies that will say, I'm not going to join this consortium because another such company or another organization is part of it. So you have to look out for that when you're dealing with this. Time. I can't tell you, putting our first project together out of our Crops of the Future consortia took almost 9 months to just get that project up and running. Especially if you have multiple members, you have to make sure that all the members are in agreement with the terms of whatever that project is going to be. So the time can be exceptionally difficult. IP, again, is one of the most sticky issues. In our consortia, we try to keep it simple. We try to not get as heavily involved in IP as such what a university would be. We try to view when a consortium funds a university that we're going to apply by dole. Even though we're not a federal agency, we don't have to apply by dole. We try to do that, which means that the universities would own the intellectual property rights. We then negotiate with them to give us licensing back to the consortium. That's our main goal. So we try to keep it as simple as possible. But IP and the agreement on IP has to be done early. So you, in order to form this consortium, the first thing they're going to ask you is, what is the IP policy of this consortium? So we work very hard to have a framework for IP on our consortium. It may be more specific once we put the consortia together, and that consortium might actually work to tweak it a little bit, but we want to have a basic framework before we start so they can make a decision, and they have to accept this framework in order to become part of the the public-private partnership. Transparency, both within the consortium and what we portray out to the public, is very important. And the public perception. So our foundation, which is required to have public-private partnerships, has heard everything like we're in bed with industry, we're not representing this group, we're not representing organics, we're pro-GMO, we're this, we're that, we're this. So the public perception of just working with industry is oftentimes hard to overcome. Again, we try to say, look, it is raising all ships to have these public-private partnerships where the private sector is paying for research for the public good. And so we want to, again, have unbiased research results that can be put out publicly. And we have requirements in all of our consortia and our public-private partnerships that data and results be made public. You can layer some things on top, like have an embargo period where there'll be an incentive for those companies to get access first to the data and results, but eventually all of those data and results must go public. So, but what are the opportunities here? There's so many opportunities. First of all, through our consortia and our agreements that we have and our grants that we've made, we have engaged all of these agencies in many different ways. Some of them are joint funders with us. Some of them work on advise us on how we should go forward with programs, but it's a great opportunity to engage the public sector and engage different government agencies. You get to engage you can create non-traditional partners. So we've been just amazed at how many partners that we would never have thought of are willing to fund areas of ag science that are really quite a surprise. And so we have then courted some groups that traditionally, for example, work in the biomedical area to come into the ag research area, and vice versa. Even some companies that you would never think of that work with us. So it's a great way to bring in partners. We fund science for the public good, and that is really gets more and more embraced by all of our partners in your consortium. And we engage stakeholders, farmers, producers all across the nation when we set up these consortia and to get input in what we should be going after. So it's just full of opportunities. And then we create networks for the future. So once you have these consortia together and they see that they work, it's easier. You know, success breeds success. So you're able to bring more of these consortia together. So here's the crops of the future. I'll let you know that all of these are our founding partners here. We have now, as I said, up to 15 partners. It was interesting that all of our partners here were international companies, but we have some American-based companies now as well in here. And the idea of this consortium is to go after the traits that we need for creating new crops in the future. So we're looking at corn, wheat, and soybean right now, but we corn, wheat, and leafy greens, but we're doing a protein piece to look at proteins, how we increase proteins in any plant, really. And because the genes are the competitive portion, we tend to look at all the processes up to the genes. So it's a very interesting consortium. I want to give a pitch out to Colorado State. This was the irrigation consortium that we formed is here at Colorado State. We made a grant to Colorado State. I laugh, and I told a few people last night, it's the only time when a proposal is submitted to us and we reject the proposal and go to them and say, we're rejecting your proposal, but we want something bigger, and we're willing to give you more money if you create this consortium. This is all the groups that are part of it, but that's just the beginning. You can see there's many of the tech and the irrigation companies, as well as a number of universities. And we just are so grateful to Colorado State. We're just now working on the first projects that are going to come out of this consortium. So thank you very much, Colorado State, for the great work you did here. And I just want to mention two other consortia that are in the formative stage. PIP, which is Precision Indoor Plants. There is a lot of work going on now to produce plants indoors. One of the things we don't know really is some of the basic biology of how we could adapt plants from outside to inside. It also offers an opportunity to grow plants for other purposes like medicinal purposes or for high-value crops that might have nutraceuticals or industrial applications or something like that. But we really need to understand plants and their traits in order to bring them inside. And the other is ICASA, which is the International Consortium for Antimicrobial Stewardship. And this, again, we've been working with the community at the universities, but we're with a number of companies to try to bring this to the forefront so that we can take a look at some of the intractable issues in antibiotic stewardship. So that's about public-private partnerships, but one of the things that I want us all to think about is that whatever projects we're doing in the innovation space, we can't lose sight of the consumer. Because as you all know, right now, as I mentioned earlier, consumers are very interested in the food that they eat. It is actually an emotional issue with most people, and we're all the same too. What we put in our bodies is something that we think a lot about. So the things that we want to put into our bodies are, can sometimes go to our very core of how we think about things. So they've never cared more nor known less about how their food was produced. And part of that is the complexity of food production now. Global in scale, so many varieties of food, all the different production methods, all of the packaging that goes along with food, everything, processing that goes along with food. So in some ways, we cannot blame consumers about not knowing everything about how their food was produced. But they want to know about the food so that they can pick. I love the point this morning, I think it was Dave that said about tipping through the blockchain, being able to tip your farmer. To me, that's really incredible. One of the things that will give consumers is to know where that food was produced. Consumers are skeptics. This is a part that we have, certainly seen in the world of GMOs and genetic modification. I don't care how much times you can tell a person, how many times you can tell a person, you probably eat GMOs every single day. As you know, most corn and soybean is genetically modified. You probably eat it every day. That doesn't resonate with people. That doesn't change their opinion about GMOs, for example. We use GMOs entirely in production of drugs. In the biomedical community, they are used right and left. In that case, consumers will say, but I have a choice, right? I don't have a choice. I'm desperate for a cure to my child, my husband, my son, my daughter, etc. And so I'm going to use whatever means necessary in order to find that cure. In the case of food, we say we have a choice. So I have a choice whether I want to eat something that has been produced through genetic modification. And so consumers can be very skeptical. And when we bring new innovations along, we have to think about that skepticism and how we're going to overcome that skepticism by the consumer. And perception is a big part of the game. Again, as I mentioned, it doesn't necessarily matter how much science we throw at you. Ask everybody to look at these two different colored blocks here. The top is much darker than the bottom. But the eyes only see what the mind is prepared to comprehend, correct? Those are actually the same color, those two blocks. As you can see, I pulled out the middle of both those blocks. And if you put something in between, you see how those blocks are really the same color. It's true with public perception. They only see, the consumers only see what they want to see. And so we have to be very cautious about innovation. When we think about innovation, we have to think how that's going to go out and be adopted. We're trying to get ahead of the game with gene editing. We were behind the game with GMOs. So we have to think a lot about what the perception is going to be of this technology. Now, I will give you another story about interesting bedfellows. How many of you know Impossible Foods? Impossible Foods is a new type of plant-based or alternative to meat, to animal-based meat. And it is created by a group of scientists out in California who use as the basis of making it taste like meat, heme. And they were going to get heme from soybean, but they couldn't get enough heme from soybean. So what they did was they genetically modified yeast. So when you eat Impossible Foods, when you eat a Impossible Food hamburger, which is now available at many restaurants and some in some stores, you are actually eating something that was produced through genetic modification. That company has been out on the road promoting GMO and saying GMO has led you to this new product. So if you're against animal agriculture, but you're also against GMO, what do you do in this situation? In the case of the hornless cow, which as we know can be an animal welfare issue to dehorn cows, we have a way through genetic modification to make a hornless cow. So which way do you go? So it's confusing to the consumer, and their perception of it is can be very difficult, but it's something we have to overcome. People love innovation. Everybody's here. We love it. We see our cell phones. We love it. But you know what? In truth, they love innovation almost as much as they despise change. So we're also faced with that fact that too much change is difficult for people to have happen. And that can happen here with our farmers. That can happen with the consumer. That can happen with even our universities and our university scientists. So it's an interesting time because we have to overcome this desire not to change, because innovation means change. And so we have to really figure out how we're going to do that. And also, I guess that we want to ask the question, how do we demystify food and science and food production? It's tough, particularly in this world now of media, right, and social media. And where any story, and remember the pink slime story, and all sorts of stories that get out about food that are inaccurate, but yet how do you then prove the accuracy or inaccuracy of those stories? So, and then science is scary sometimes. How do you demystify it? Here's a young girl with a Brussels sprout. So food doesn't have to be scary, and neither does science. Now, I want to tell you, I was just reading about Brussels sprouts because I hated Brussels sprouts as a kid. Any of you that are around my age, which is 60, know that when we were kids, we'd take frozen Brussels sprouts, throw them in a pan of water or steam them, and that's what you had on your plate. There was no kid in the United States of America that liked Brussels sprouts. I can tell you that right now. I just read that the demand for Brussels sprouts has gone up by 100% over the past 3 years. 100%. And this is one of the reasons I think is bacon, because now when you get Brussels sprouts in most places, you get them with bacon. But you also get them in all these different delicious ways they're prepared. So, this is a little putting off for Brussels sprouts. I want to give Brussels sprouts some props here. But the point is here, we have to stop making science scary. I was on a panel just the other day, and someone in the audience said, why don't we change the word science? Science is scary to people. And I said, no. I was standing up. I said, we're not going to change the word science. Science is science. How do you change? That's asking questions about life, right? You're not going to change science. So what we need to do is see how we can demystify it and see how we can overcome people's perception and work to communicate science in the best way that we can. Finally, I want to end by just saying the biggest threat to the future of the planet is not agriculture. In fact, agriculture is the solution to much of this, but it's in our inability to work together, and we have heard that. And so in the world of agriculture, what has made me so proud is that we work across borders. And in science, we work across borders. Scientists have nationalities, but science has no nationality. We work across these borders on agriculture. We have trade in agriculture. We work in science and agriculture across borders. We don't have an R&D behind the science that we do. So we need to all work together in order to face these absolutely incredible science. And we talk about 2050 and having 9 billion people to feed. But the next 35 years is not just the most important 35 years in the history of agriculture. It's the most important 35 years in agriculture. We can't wait to 2050, guys. We have to do things today, and that's why you're all here in this room. This innovation is happening today that's going to impact us and let us deal with 2050. We can't wait. We have to be in the game at the highest level and producing that innovation that's going to happen. I love this. Bill and Melinda Gates said, imagine our future and change the world, be the impatient optimist. I'm also always going to be an optimist about agriculture. It is just an incredible time to be here. And then I want to end with Norman Borlaug, because in science, one of the great advantages that we have in agricultural science is that we work so directly with the farmer. And if you know the story of Norman Borlaug in the Green Revolution, which I believe what today we're in is the, as someone mentioned this morning, the biological revolution, or the Green Revolution 2.0, as I like to refer to it. Norman Borlaug, on his deathbed, surrounded by his family, his very last words to his family were, take it to the farmer. And so having to, even this room today where we have so many producers represented along with university administrators and scientists, is the way that it happens here in agriculture. And I'm so proud of all of you, and I'm just so happy to be in this space right now. And so I'm looking forward to this afternoon's session. So thank you very much. Are we going to sit in the chairs?
Yes.
Okay.
Well, Dr. Rockey, I think that the audience would agree with me in saying that it's very apparent why your expertise and insight has been so groundbreaking within the agriculture research community. I also understand that you can answer one of the questions that was actually posed to our previous panel. So if you don't mind starting with just a little insight on your opinion for a DARPA for agriculture.
Yeah, so someone asked the question this morning about DARPA for agriculture. There is actually in the 2018 Farm Bill a proposal to start Ag ARDA, which is the Agriculture Advanced Research and Development Authority. And it is not actual funding for it, but is an authorization to start it. We've actually been working very closely with the Congress about the language there and with the USDA. The interesting thing about our foundation is that because we don't have an ARPA-E or a DARPA like DOE or Defense has, our foundation has in many ways taken on that role. However, because we have to fundraise and because we have to find the match, we can't work as closely with, as quickly as a DARPA or ARPA-E could do. The other thing that's important is USDA needs this, because then the technology is taken right directly back to the USDA when it happens. So I'm looking forward to that. I'm hoping that it'll make it out of the Farm Bill and that we'll be able to work towards a new AGARDA, I guess they say, AGARDA.
Perfect. Well, jumping back to your PowerPoint slides, actually, we had a question that says, a slide of yours showed a graph of a private R&D funding, which took off around 2010. What happened?
What happened? Well, a part of the reason that you see is, I think it's twofold. One, I think, again, there's been expansion of, although there's been a lot of consolidation, there's been expansion in the private sector, period, in the ag world. But secondly, you saw that the federal funding went flat, and so there's been a desire on the part of, with federal funding flat, there's been a desire on the part of the private sector to take on more. I will tell you that the private sector, as well as I lose sleep over it, is who's going to do the basic science with a flat budget in agriculture. The private sector asks for that science. That's part of what we're doing with our consortia. But I think that it's more reflective because the public sector funding has gone down and the private sector has to make up the slack.
On one of your slides, if I recall correctly, it said that innovation is a way to help improve agriculture. So this question kind of stems from that, and it says, if it is so clear that science makes a difference in agriculture, why is there still resistance from our producers? And how do we encourage our producers to adopt these agricultural technologies?
Well, I don't know if it's resistance on the part of the producers. I think that when adopting any new practice that is based on science, there's a lot of things that go into the producer that we tend not to focus on, and one is the economic return for the producer. So the producer, in their mind, has to take on a lot of issues. You know, how's it going to work in their system? What's it going to affect for their bottom line? What does that mean for the future? And oftentimes it's hard to take new adaptations of science that are going to have a long-term result to the producer and a positive result to the producer, and make the changes now. Now, one of the examples I'll give you is cover crops, which we have a number of programs trying to increase the use of cover crops. We have an audacious goal of increasing the acreage of cover crops or soil health promoting practices by 100 million acres in 5 years. I don't know if that's going to happen, but to make that decision about using cover crops, not only do you have to fit that into your system, but oftentimes the result of that and the positive result can be years out for a farmer. So I think there's a lot of complexities that go in there. So I don't think farmers are resistant to it. I think it's just it's often a complex issue to take some of these new technologies and innovations and apply them on their farm.
And now we'll take a quick turn to the consumer perspective. This question asks, growing consumer interest in the food system has resulted in growing concern as well. What would you say is the best way to address these concerns?
Well, we've had a lot. I mean, at every meeting I'm at, we talk about communicating with the consumer, and I still think to this day we don't know what quite works with the consumer as far as communicating. I'll give you an example. I don't know how many of you know about slow grow chickens. Any of you in the poultry industry here? But there's been a lot of interest in perhaps asking for chickens to be more slow grown. The idea is that when we've bred chickens to be such fast growers that they have health issues. And if you know with the broiler industry, are any of you poultry folks out here? Because you'd know this better than I. But regardless, in most cases, poultry broilers are taken at 7 weeks. So they only live a short time. And the idea is to take them at 9 weeks. And that way you wouldn't have to breed for these big chickens that break their legs and things because they're so big, which is actually not true, but nonetheless. So we did an interesting study because the other program that we funded was about bone breakage in cage-free environments and egg layers. Because what happened was the community has made a commitment to go cage-free, which is actually not cage-free if you know. It just means not individual cages. But what happens, chickens, as you know, can be very aggressive, and they fight with each other, and they break their bones. And up to 80% of chickens can have a broken keel in a cage-free environment. So we're doing studies of how to improve bone health in chickens. But why didn't we do this before the industry decided to move and commit to this? So what we did with the case of slow growers, we had a quick study take place which looked at consumer acceptance of slow-growing chickens. And so we went to a group and we explained about, the issues and why some people want slow growers. And almost everybody that we surveyed said, yes, I want slow growers. I'm going to look for that label, although don't panic anybody. There's no labels about slow growers. But then if you explained that what we're really trying to do and went back and said, we're only talking about 2 weeks difference. We're talking about increased number of chickens that you're going to have to raise to be able to produce the same amount. The environmental impact for keeping chickens alive for 2 more weeks is enormous. And so we came back then to them and gave them that information, and there was a totally different perception about whether or not people wanted to accept slow growers. And slow growing chicken, and I said, actually we should be looking for a label that says never slow grown. That would be the label that you want to look for. We don't really know how to communicate correctly with consumers. We don't. And so we need to learn that. But it is so hard and complicated. And this world that we work in, where one tweet from someone can change the whole population's perception about something, is really difficult to handle. I think that we as scientists have gotten better at it. I think, though, one of the places to be able to communicate this is through the farmers and through the producers, because farmers and producers are some of the most trusted people on the planet. And scientists come a close second to that, so surprisingly. So between farmers and scientists being able to talk about this, I think we can make headway.
Okay. And I think we have a little bit of time for one more quick question. So Malia?
Aren't any yet.
So if you didn't hear the beginning, what areas of partnership should there be in FFAR? We're pretty broad. We cover most areas. I will tell you the areas we don't cover, and unfortunately it has a little bit to do with today. We don't cover food security and food safety because we're very small. The USDA has $3 billion or more of research every year, and we have $200 million of research in 5 years. So we've purposely not gone in that area because there's quite a bit of food work and funding in food safety and in food security. I think one of the areas that we need to do more is at the community base on food access, and one of the areas that we're trying to go into that we haven't yet is the whole area of food as what they call food as medicine. But what it really is means that how do you understand human nutrition and the requirements of nutrition and go back and relate that to production agriculture? There's huge gap areas. NIH funds $3 billion a year in nutritional studies, but we oftentimes don't translate that back to our production systems and what we should be growing and where we should be growing it and how we should be producing it and how we should be processing it. So that whole area is an area we're not in yet, but we'd like to get into that area very much. And we actually are having a convening event, I'll put a plug in, next year called Growing Better Health, which is going to take a look at that. And we're also right now working with the other federal agencies, NIH, FDA, and USDA on this issue, trying to get the agencies to talk about it first, and then we'll move on to what research we can fund. Well, thank you
Dr.
very
Rockey,
much.
yes, thank you very much for being with us today. We'd like to give you a gift for our gratitude to you, and especially just to highlight your commitment to agricultural
That is
research
so
and
nice.
fostering innovation in ag.
Thank you so much. That's wonderful. Thank you. Oh, this is great.